Okay, guys, we are live. Let's get the show on the road then. We are back. We've got another Monday morning ready to go. Right, let's get our PowerPoint up and ready to rock. I hope everybody's had a good weekend. I know the weather's been a little bit grim, so I'm hoping we've managed to at least stay warm, keeping ourselves dry as well, hopefully, and most importantly, safe as well. I know over the weekend, there's been trees getting blown down, fences getting blown down all over the place. So, as long as we're all safe, I hope we've all had a good weekend. And I can't believe we're into December by the time this weekend rolls around. Christmas is coming, guys. And you know what? For all December seems to be a time of year where people slow down a little bit and stop exercising quite so much, but tends to be the time of year that we're having a little bit more flexibility in our diet. I guess we've got a little bit more treats coming in. The quality treats, the Maltesers come with Christmas, so it's a good time to start thinking about, right, okay, I'm going to start getting a little bit more active now. I'm going to start getting a little bit more sort of like I say, getting a little bit more movement into my day. It doesn't have to necessarily be exercise, of course. Movement still counts as a form of exercise, running the hoover around, dusting, standing and doing the washing up. It all still counts as movement. And it's a really good time because there may already be one or two of you that are thinking, do you know what, from January I'm going to think about, right, I'm going to get on a healthier diet, or I'm going to lose a little bit of weight, or I'm going to try and get a little bit fitter. Why not start now? Why not start now? Nice and slow, just bring in one new thing each week. Like, this week I'm going to try and make sure that I get, I don't know, it might be, if you don't eat much fruit and veg, it might be just some fruit and veg with each meal. And then next week you keep that up, but you try and, I don't know, get 8 hours sleep a night, or you try and get enough water every day. You've got 4 or 5 weeks till the end of the year. You can set up yourself maybe 5, at least 4 new habits, really, and start slowly getting into new habits, so that when everybody else starts on January, we're already going to be a month ahead. You're already going to be a month ahead of everybody else. So now's the best time to start. Don't wait till January, especially given that we're probably going to be treating ourselves a little bit more when Christmas rolls around as well. So of course, a big part of getting a little bit more active, getting fitter, is understanding our own body a little bit more as well. Of course, something that sort of doubles up with what we looked at with the skeleton. We know that we need to look after our bones. We know what our bones do, and we've talked about that quite a lot now. But we've also got our muscles in our body as well, which of course work as, I guess, the other part of the jigsaw to help us move. We've got our skeleton, which fits together in a certain way that allows movement. But we can't move a bone by itself. We need muscle to move the bone for us. But we also have different types of muscles. So that's what I want to look at first of all this morning. But just before we do jump in and go any further, just in case this is the first session that you're catching, or you've missed it on the last couple of weeks when I've talked about it, beneath the YouTube video, you should have a little drop-down box that's going to have any extra information that you might need. So it's got my email in there. It's got a link to today's fitness session in there as well. Links to all of our social media pages. So we've got our Instagram, our Twitter's in there, Facebook, even LinkedIn is in there as well. There's a link to any extra learner sort of supplementary info that you might need. What to do if you have any concerns, sort of browsing safely online and stuff like that. That's all in there as well. And then we do have a link to a survey, and the same with every session that you do on every course that you do. That's the session, the survey needs filling in for each session that you do, but won't even take 30 seconds or so. If you click on that link, it'll take you straight to where you need to be. But you can put your answers in there, and then the answers come straight back to us. So you don't need to worry about like download it, fill it in, save it, send it back. None of that. So it's nice and easy, not even 30 seconds, and you can get that done. So make sure we do the survey for each session, and any extra information that you might need is in that little description box under the video as well. Like I say, my email's in there if you need to get in touch for anything. If you've got any questions, please do drop me an email if you are struggling with anything, or like I say, if you've got any questions. Okay then, guys, let's get into it then. Let's talk about our different muscle types, because when we're thinking about muscle, I think a lot of us, probably our mind immediately goes to the muscles that we can see and that we can tense, you know, and probably, like, you know, we can look at in the mirror. The sort of muscles that you see on the edges, like on the outside of the machines when you go to the gym, and it's saying like, okay, this one's going to work your delts, this one's going to work your pecs, you know, and that is what we call actually all of those types of muscle fall under this one here. So we call it skeletal muscle. So we've got our skeletal muscle, yeah, and it's just muscles that are attached to the skeleton by tendons, yeah. So the way that the muscle is going to work with the bone, for example, so going back to our skeleton session, we've got the humerus in the upper arm, yeah, we've got the humerus here, this bone. So we've got the humerus doesn't really want to move, yeah. The humerus won't move by itself. We need to move it. In order to move it, that movement's going to probably come from either the shoulder joint, yeah, or I guess to give a bit of a better example, if we look at these bones in the lower arm, yeah, so we've got a natural hinge at the elbow, so the elbow can bend, yeah. So we've got bicep and tricep, which we're going to have a little bit of a look at this morning as well. So we've got bicep on the top, tricep on the bottom, and they actually work opposite each other. So in order to bring my hand in towards my shoulder, my bicep there is going to shorten, yeah, but in order for that to shorten, the tricep gets longer, and then the complete opposite for the other part of that movement as well. So in order to bring my arm out, the tricep's going to get shorter, almost as though there's someone pulling it, and then the bicep gets longer and stretches. So that is how we get our movement. Like I say, our skeleton allows movement, but our muscles sort of facilitate it, really. I guess it doesn't really create movement, because that's your brain and your nervous system, but it's the next best thing. Yeah, those muscles, those skeletal muscles, actually allow that movement to happen in what we would call a voluntary sense as well, you know. So again, that movement that I just did was totally voluntary. That's through choice. I'm asking my body to do that. You know, it's the same as turning your head to the left, turning your head to the right, whatever it might be, shrug your shoulders. It's all voluntary, you know. It's all muscle that you have control over. And you know, 99.999% of the time should only move when you tell it to, or when you choose to. So those are the muscles that, you know, are going to be the most common that you see on, like I say, exercise kit and stuff like that. Because, like I say, those are the ones that we can exercise a lot more effectively by choosing what we do and voluntarily moving through whatever exercise it is that we're doing. But that isn't all the muscle that we've got. Yeah, so we do actually have different, like other different types of muscles as well. So not just the ones that sit on our skeleton and, you know, allow us to move and we can flex them and they look good on Instagram. So what we've actually got, we've got 3 different muscle types in the body. So we've got skeletal, like I say, and skeletal, like I say, totally voluntary. But then we've got cardiac muscle. So cardiac muscle is only found in the heart. So if you ever heard of like cardiac arrest or anything like that, of course, it's to do with the heart. So that just makes it nice and easy to remember that. Cardiac muscle is only found in the heart. Yeah. Now the big difference with that sort of muscle being, it is involuntary. You don't tell your heart to beat all day, every day for the entirety of your life. You know, I'm not very good at multitasking, so I'd be no good if I was like totally just focus on making my heart beat all day. I wouldn't get another single thing done. But yeah, the heart will beat by itself. It's not something that we need to control or to sort of constantly be thinking of. So when it comes to the heart, like I say, that muscle is all classed as cardiac. Yeah. And like I say, from birth to probably the minute that we pass away, our heart is going to continue to beat of its own accord. Yeah, as opposed to, like I say, if I want to put my hand above my head, you know, that needs to be a voluntary choice. I need to choose to do that, and I need to make that happen through these skeletal muscles. So that's a really big difference between our sort of the first 2 types of muscle that we've looked at. We've got skeletal, which is totally voluntary, Like I say, it connects our bones. And then, like I say, we've got cardiac as well, which is in the heart, and it's going to beat by itself. Yeah. We, to an extent, do have a little bit control of over our heart rate. There's a lot of things that can either speed it up or slow it down. You know, speed it up, we can exercise, stuff like sugar, caffeine, drugs, stuff like that can raise your heart rate. Then of course stuff like sleep, meditation, stuff like that. Other medication maybe can actually slow it down a little bit as well, if it can help relax you as well. So we have control of our heart rate to an extent, but we don't control whether our heart beats or not. Yeah, so that is the difference between voluntary and involuntary. And then the last type of muscle that we've got to look at is smooth. So we've got smooth muscle, and that is found in the internal organs and in your blood vessels. Yeah, so your veins, your arteries, your stomach, your spleen, your liver, your kidney, whatever it might be, your lungs. It's all this smooth muscle. Yeah, and again, it's involuntary. You don't need to tell your digestive system to pass food through it, you know, and extract food and stuff like that, and to do its job. It just does it, you know. That's part of the reason why we can end up eating far too few calories than we actually need. If you've got like a Fitbit or something like that that tells you that you've done enough exercise to burn 500 calories for the day, you know, you might think, okay, I'll replace those 500 calories and, you know, my weight should stay about the same. But that's not going to be the case, because what we've actually got, our body doing what it does, our brain thinking, our stomach digesting, all our internal organs working on this involuntary basis, actually burns calories as well. So it's energy, you know, your body needs energy to make these things happen. So that is why they would say, even if you're only burning 200-300 calories a day through your exercise, your ideal calories for the day, again, depending on your age, your weight, whatever it might be, your ideal calories for the day might still be, what, 1,600-1,800. You know, so it's something to just watch out for when we're trying to set ourselves a little calorie goal for each day, because we do need to be aware that our body, through these involuntary things, our heartbeat, and it does still burn calories. It does still burn calories, and it does still require energy, guys. But those are the three major types of muscle that we've got: cardiac, skeletal, and smooth. Skeletal is the only type of muscle that is voluntary and that we have direct control over. And of course, cardiac muscle found in the heart. Smooth muscle is your organs and your blood vessels. Okay, guys, cool. Right, so we've got a handful of our major organs in this word search. So we're going to spend 5 minutes or so just on this slide. And I want you to try and just pick out as many words. So we're looking at organs here, yes? So internal organs. Again, we haven't covered them yet, so I wouldn't expect you to know all of them. I wouldn't expect you to have even come across all of them before. All we're trying to do, see what words we can pick out. If you see something that looks like a word, but you're not sure if it's an organ, make a note of it. And then it'd be interesting to just see which of these words are new to you, or maybe some of them are words that you've heard before and you're not sure sort of what they refer to, or maybe they are words that you know, which will hopefully make it a little bit easier in figuring out what we're trying to pull out of this word search here as well. So off the top of my head, I know that we're looking for intestines, pancreas, lungs, esophagus, liver, kidneys, and stomach. At least those, yeah? If you want a little bit of a hint, there's some that you can look for. So we'll have a few minutes, and then I'll spin on to the next slide, look at the answers, and then we can start to actually have a look at where these are found in the body, and just a little bit of a fun fact of each of them. So we're working our way through, getting more familiar with our own anatomy, I guess. Like I say, it helps us, I think it helps us picture the way that our food choices and potential sort of lack of exercise might affect the body if we understand the body a little bit better. You know, what's going on in there, guys? What's going on? It all helps to know. when it comes to managing our own fitness and our own sort of weight and well-being as well. Okay, right. So as always, guys, I'll be watching along in the live chat while we're on. Of course, if you're watching this session later on in the week, if you're watching it back, then like I say, let me know if you have any questions, get stuck with anything. And if I do move on to the next if I move on to the next slide a little bit quick, but until like before you found all the words, or you want to spend a little bit longer trying to find the last couple, just pause it when I'm ready to move on, and then you can just press play when you're done and watch the rest of the session from there, even if you're watching live right now. Okay. Right, guys, so rolling on. Let me know if you did find any. Okay, so what we've got intestines across the top. Next one down was pancreas. Then we had esophagus. That's a bit easier if I can actually click. Esophagus was there. Then we had liver, kidneys, stomach right at the bottom, and then a couple coming down over. We had brain, spleen, and the last one being lungs over there. Yeah, so some of those words, like I say, you may well have come across before. I'd be surprised if you have never heard of a brain or lungs, or maybe even your stomach. And then we have some that are a little bit more out there as well. You know, what do they do? What's their jobs? You know, intestines, pancreas, esophagus, all of those as well. And remember, these are all smooth muscle. Yeah. So let's get a look at where in the body they'll actually be found. So let's go slideshow from there. Cool. Right, guys. So we've got, if we can see there, so we've got the heart, of course, nice and central. Yeah, so our heart is nice and central. Contrary to previous belief, it is in the middle of our chest, right behind our sternum. Of course, this is what we talked about when we looked at the skeleton. The sternum, the breastplate, is there to protect the heart and the lungs, which sit behind it. But of course, the heart is dead center behind the thickest part of that bone. And the reason that we would put our hand on our left-hand side to feel our heartbeat, or the reason that we think it's over to the left-hand side, is because the heart tilts ever so slightly to the left. But it's also the left-hand side that beats harder, because that is the side of your heart that sends oxygenated blood out and around the body. And we're gonna have a good little sort of in detail look at the heart in just a minute, and the role of the heart, what it does in the body, and how it does that role. You know, like I say, it's a fascinating thing that it just works by itself for our entire life, sort of its own accord. You know, it's really interesting the way that it works. But yeah, the heart, the left-hand side squeezes a lot harder, which is why we feel that beat on the left-hand side of our chest a little bit more than on the right. And the esophagus we've got, and that is the pipe that your food will go down to, like into your stomach. So that's your esophagus, not to be confused with your trachea, which is the windpipe. Yeah, so your trachea will take the oxygen down into your lungs. Again, a big part of your sort of like your cardiorespiratory cycle. So your heart and your breathing cycle, your heart and your lungs working together. So we've got, our trachea is where our air and our oxygen goes down into our lungs, and the esophagus is for food. Okay, of course, the brain isn't included on this picture because this individual's lost their head, but we know that the brain sits in the skull. The skull gives it a lot of protection, and the brain is it's like our command center, really. It's like our central hub. It's where all of our choices and all of our commands and all of our signals for the rest of the body come from. Okay, then, of course, we just talked about what the lungs do as well. We were discussing the lungs and their job in bringing oxygen into the body. which the blood then picks up and gets pumped around the body. Yeah. And we've got the liver, which produces bile and sort of works as part of our immune system as well. And our immune system is sort of like our body sort of cleaning itself and maintaining itself. What else have we got? The stomach. Of course, the stomach is where our food goes to be digested and start to get broken down, so our body can use the nutrients for it, from it. Sorry. Now, the stomach. Actually, a bit of a fun fact about the stomach: the acid in our stomach is so strong that it could burn right through your own hand if it got onto it, which it just tells you how tough our stomach wall is if it's maintaining acid that is that strong. But yeah, we have acid in our stomachs that could realistically burn straight through our own hand, and I believe that is where the inspiration came from for the xenomorph in Alien, which of course has acidic blood. So yeah, a little fun fact there, but it is actually in our own it's in our own stomach. We have acid that is sort of just as strong, really, could go right through our own hand and through our skin. Okay, so stomach. Then we've got spleen. Next one down is spleen, part of our immune system. It plays a big part in the production and recycling of blood cells, which are going to help transport oxygen and fight off sort of intruders in our body. Kidneys. Kidneys is a interesting one. Did you know, actually, if you have a bad kidney or a failing kidney, and you're getting a transplant from somebody, and they put the new kidney in, I actually found out they sometimes leave the old kidney in as well. So rather than take it out and put the new one in, they just leave the old one in. I'm guessing I believe it's partially through the hope that through the reduced workload of that one having to do it, that the knackered one might slowly sort of fix itself and start to work again. I don't really know if there's any benefit or downside to having 3 working kidneys. You might feel a little bit seen off if you're giving someone one of your kidneys and then it turns out they're walking around with 3 while you've got 1. I don't know. I've never donated a kidney. I couldn't tell you, but I would imagine so. But yeah, I thought that was really interesting as well, that they'll sometimes leave the old one in. What else have we got then? What else have we got? Okay, we've got our intestines at the bottom. So we've got our large intestine and our small intestine, which is where our sort of partially broken down food, mush, whatever comes out of your stomach, can actually start to be absorbed into the walls of your intestine. And again, it's extracting stuff that we're going to be able to use in our food and slowly pushing it down, extracting what's good, leaving what's not, and for it to ultimately pass out the other end, as we all know and as we all do. And then the last one to mention on there is the pancreas, which actually helps with digestive enzymes and helps release different hormones and different chemicals into the blood. Okay, and I think that was all of them on there, really. The appendix is not something that we really use so much these days, and especially if it's at risk of rupturing or bursting, which can be fatal, they'll tend to take it out. But appendicitis is still something to watch out for. So if you're getting pain in that area, bear in mind it's always on the right hand side. Always on the right hand side. That pain lower down, sort of lower than your stomach. Like I say, if you do get pain, just because our appendix doesn't really have much of a function these days, doesn't mean we don't have to go and get it looked at if it's causing us pain. Okay, of course, bladder is probably one that we're a little bit more familiar with as well. Of course, it holds our urine, it holds our liquid waste until we're ready to pass it. And yeah, I think we've pretty much covered all the rest of them. So yeah, it just gives us a bit more of an idea, like I say, what we've got inside, in our rib cage and in our torso, all the different jobs as well. And again, remember that all of these are working all day, totally involuntary. And again, it's part of what they say. It's not just, you know, I'll even say it sometimes, you know, your body's like a car. If you don't put any fuel in it, it's not going to go and it's not going to work, you know, and that's not just in terms of being able to move. That's in terms of all of this going on as well. If all of this is active all day, every day, it's using energy. Yeah, so we've got to make sure that we're getting enough energy to help our body do what it's got to do as well. Okay then, guys. So, as promised, we'll have a little bit of a more in-depth look at the heart as well, because, like I say, the heart is. I think of like if the brain is like our battery, I guess our heart's kind of like our engine. Yeah. Again, just sticking with the car analogy, and I'm not a car person, really. So that's about the extent of my car knowledge, to be fair. But right, what we're going to do, yeah, we're going to actually draw a little diagram. So if you could just get yourself a pen and a bit of paper, ideally 2 different colors. Yeah, so different colored pens, different colored felt tips. You might want to do a pen and a pencil, however you want to do it, because we're going to actually at a point we're going to mark out and sort of indicate what blood is carrying oxygen and what blood isn't carrying oxygen, because that is going to determine sort of where the blood needs to go, which of course affects how it moves around the body as well. So I'll just give us a minute, grab yourself a pen and a bit of paper. Of course, if you're watching later on in the week, just pause it if you need it, take as long as you need to get your bit sorted. And we will slowly make our start for those of us that are ready. So again, what we've got, our cardiorespiratory system, cardio to do with our heart, respiratory is to do with breathing. So we're thinking about how our breathing, our lungs work together with the heart to do the job that they do. Yeah, which is to be this system. So what we've got, we're starting off with 4 boxes, all the same size. Yeah. Now, of course, this isn't what your heart actually looks like, but this is what our heart's going to look like. So the 4 boxes that we're drawing, you can think of 4 different rooms in the house, but what it's representing there is the 4 chambers of the heart. Yeah. So the heart has 4 separate chambers, 2 on the left, 2 on the right, and they're divided by a thick wall of muscle down the middle called the septum. Yeah, so a thick wall of muscle down the middle called the septum. And we'll get into it in just a little bit why that wall is so important as well. So yeah, we've got our 4 chambers, our 4 rooms, 2 at the top, 2 at the bottom, and divided down the middle with a thick wall called the septum. And that might be a word that you're familiar with. You might have come across it before. It's also used to refer to the bit that divides your left nostril from the right. So that's what they call it. If you get that pierced, it's called a septum piercing. And again, that's a divided wall. It disconnects you. It separates the left side from the right side, same as it does in the heart. So that's the septum, and we've got our 4 rooms. Okay, so I'm going to move on to the hiccups. I'm going to roll on to the next slide. If you need to take a little bit longer, like I say again, just pause it there. Okay then, so step 2. So for step 2, all we've done, the only additions that we've made in step 2 is we've labeled the left-hand side and the right side. Now you're probably looking and thinking, why is the right-hand side and the left side swapped? Well, if you were to pick up this piece of paper and hold it facing away from you and put it on your chest, you would find that the bit that says left would be on the left-hand side, and the bit that says right would be on the right. It's almost easier to imagine that this heart is in the chest of somebody that is stood looking at you. Yeah, so if they're looking at you, the left-hand side is their left and the right-hand side is their right. Yeah, so that's the way that we look at it when we're looking at the heart. So it's almost as though it's in someone else's chest looking at you. Or again, once your diagram's done, if you pick it up, face it away from you and put it on your chest, it'll line up perfectly, left side and right side as well. Okay then, so that is why we've got the left-hand side on what looks like the right and the right-hand side on the left. Yeah. Okay, step 3 then, step 3. So now that we've split up the left and the right, we can start to distinguish a bit of a difference between the top and the bottom as well. So between the top and the bottom, so on the at the top, we have got the right atrium and the left atrium. Yeah, so the right atrium and the left atrium. And the way that I remember these, because the way that blood flow works, and again we'll see in just a second. In fact, I'll just spin on to slide quick. If we see that blood comes into the top of the left atrium, yeah, it comes into the top of the left atrium. So I think about it as being almost sort of like open top to cause for something to flow into it, which is what an atrium is. I've just pulled up the official definition. An atrium is an open-roofed entrance hall or central court. Yeah, so it's open-roofed. And again, for blood to flow into it, it needs to be open-roofed. So I remember the atrium is at the top. The atrium is at the top. And the ventricle is at the bottom. Yeah, so the bottom chambers, left and right, are the ventricles. So atrium at the top, ventricle at the bottom, and of course we've got our left and our right hand side from our left, from our last slide. So now we've got a distinctive individual name for each chamber. Yeah, so we've come a long way from this first slide where all the rooms, all the chambers look the same, there was no difference between them. Well, they've each got their own name and we know where they can be found. So what do they do? Yeah, we know the basic sort of layout. We've got the plan, we've got the ground plan, we've got the blueprints for the house, but how does blood move around it? I guess, how does it do its job? So in order to make that make a little bit more sense and visualize that a little bit better, what we're now going to do, we're going to draw a box off to the left-hand side that's going to represent the body and blood flow to the body, which means everything sort of but the heart. And then over on the right-hand side, we're going to do another box that says lungs, and that is going to be, again, the blood flowing to and from the lungs in relation to the heart as well. Yeah. So we've got the body over to the left and the lungs over to the right-hand side. Just so we can visualize this a little bit better. So 2 boxes, one on the other side, left says body, right side says lungs. And again, in a second, we'll see why it's makes a little bit more sense to put it down there that way with the body on the left, lungs on the right. Okay, guys, so if we're about there, so we've got our 2 atriums, our 2 ventricles, making our 4 rooms, septum down the middle, body on the left, lungs on the right. Then we can actually start to look at the actual cycle that our heart and our lungs play such a big part in. Okay, guys, let's get into it then. So the main function of the heart is to provide oxygen and therefore oxygenated blood to everywhere in the body that needs it, which just so happens to be everywhere, really. Again, our organs, our muscles need oxygen to work and to move. So the oxygen that, of course, we know that we need to breathe it. It comes in through our lungs. But then what? Where does it go from there? And that's where we're going to pick up. So we breathe in. So we breathe in, we brought in a load of oxygen. The oxygen is in our lungs, yeah? Our blood passes sort of close enough to our lungs, not quite really through our lungs, really, I guess, but through the muscle of the lungs, rather than filling the lungs, and it passes close enough to actually pick up some of the oxygen. Yeah, so it picks up the oxygen just like a just like a delivery van goes to the depot, picks up its its load for the day. When your shopping's coming online or whatever it is, someone goes, picks it all up in one go, brings it to you, and this is going to be exactly the same. So your blood is that vehicle, yeah. So your blood goes along, picks up the oxygen, and then it needs to get to everywhere in the body to drop it off. Yeah. Now, in order to get everywhere in the body, it needs sort of boosting around your system, I guess you could put it that way, or really it needs pumping around your system, which is exactly what your heart does. Your heart functions as the pump. Yeah. So the blood, with all of its oxygen, comes to the left atrium, drops down through a little valve. So the atrium and the ventricle will always be separated by like a little valve, which only lets the blood flow one way, because we only want the blood to flow one way. Yeah, so it'll pass down into the left ventricle, and then from there, through a big one major artery, gets pumped out as your heart squeezes, and then your blood gets sent with all that force around your entire body. So this blood vessel splits off into loads of different little sort of roads, little sort of side roads, and delivers oxygen or takes the oxygen to everywhere that it needs to be. So thigh muscles, calf muscle, stomach, brain, everywhere that it needs to go. And it is forced there through this system by the heart contracting. So your heart pumps, all the blood comes out on the left-hand side, goes around essentially to where it needs to be, which we've got marked off just as the body. Yeah, the parts of the body that require the oxygen. So we've actually as well marked on the left-hand side that the red color that we've used here for these arrows and to fill the left side of the heart, that represents oxygenated blood. Yeah, so that blood has oxygen because it came from the lungs where it picked it up. Yeah, the blood before it gets to the lungs isn't carrying any oxygen, but once it's been to the lungs, it's carrying oxygen, comes into the heart, gets squeezed around the body, and gets that oxygen to where it needs to be. Yeah, it delivers, it delivers your shopping. It delivers that oxygen to wherever it needs to be, and helps that muscle or whatever it is to continue working. Okay, so far so good, and that's half of the cycle actually done. We've picked up the oxygen and dropped it off where it needs to be. So what still needs to be done? Well, what we need to do from there, or what needs to be done from there, our blood then, like I say, isn't carrying any oxygen. So in order to repeat the cycle, it needs to go and pick oxygen up again. It needs to get back to the lungs to get more oxygen. Yeah. So in a similar way, it's going to make its way back to the heart for a little bit of help, getting pumped back round to the lungs to where it needs to be. So what we get then, we get a new color. Yeah, so we're using our second color because our blood is no longer oxygenated. Yeah, it's no longer oxygenated. So on this case, we're making it blue. Yeah, so it's deoxygenated blood. It only has one job now. It is to get back to the lungs to get more oxygen. So again, it comes into the atrium. So the blood flow always comes into the top of the heart. Yeah, and that's what I'm saying. It always flows into the top, which again, if you think of an atrium as an open roofed room or building or whatever it is, without a roof, means that the blood can flow into it. And that's how I remember that the atrium is at the top, which means that the ventricle is at the bottom. Okay then, so into the right atrium, down into the right ventricle, and again forced out as the heart pumps. So in the same pump that sends the oxygenated blood from the left side, it also sends the oxygenated from the right side to the lungs. Yeah, every time your heart beats, it's doing both of these at the same time, sending oxygenated blood out and sort of calling deoxygenated blood back round to the lungs as well. And that's every single beat. Yeah. And again, it's really interesting when you think about it, like it's done that since the minute you were born, hopefully without much problem as well. And that is really the full cycle there, guys. So from there, I think it makes it a little bit clearer to see why this wall down the middle is so important, our septum. We don't want really oxygenated blood getting diluted with deoxygenated blood. Like if you imagine that this wall had a hole in it, some from this side would get into that side, some from the, and vice versa. Some from the right would get into the left, some from the left would get into the right. So we would end up with blood going back to the lungs that was already carrying oxygen, so it's a waste sending it back to the lungs. That blood needs to be elsewhere. And of course, if you are doing exercise or whatever it might be, you don't even have to be doing anything really strenuous. But if your body is asking for oxygenated blood like it always is, and it's diluted, by deoxygenated blood, if any of this blue gets into this red side, then the blood that is going out into the body isn't carrying as much oxygen as it should be. Yeah. It might only be sending 80% of the oxygen that it needs or whatever. So you'll end up getting dizzy and you'll end up not feeling very well because, like I say, your blood can actually start to mix. And we haven't got this very clear oxygenated on one side, deoxygenated on the other, this really efficient system that's going on, where all the blood that is carrying oxygen is going to somewhere where that oxygen can be some use. And all the blood that isn't carrying oxygen is making its way back to the lungs to pick up more again. Yeah, so it just keeps the right blood in the right place, really. So yeah, that's why this wall is so important. And again, our lifestyle choices can actually affect that as well. Certainly stuff like recreational drugs, there's all sorts, and our food choices as well can sometimes affect our heart health as well. Okay, cool. So yeah, like I say, that is the full system, or the full cycle. Now remember, we've marked on the right hand side that the blue and what the blue color stands for. So now we've got our two colors, oxygenated and deoxygenated. And yeah, it's almost like a infinity, isn't it? Like a figure 8, which I guess is quite fitting, really, that it's not quite infinity, but this cycle goes on for your entire life. So it might as well be, from our own perspective, infinity, really. So yeah, we've got, like I say, just a nice clear visual of how the blood moves around the body and does the jobs that it does. Of course, if you look in a textbook, or if you ever did, even look at an image search of a real heart, it doesn't look anything like this, but at the same time, it helps us visualize what's going on. And then when you see the 4 chambers, it makes a little bit more sense what's happening in there as well. So the last thing really that we need to mark on this little diagram that we've got, the last thing that we need to mark is some of the major blood vessels that play a huge role, really. So we've actually got 4 that we're going to look at here. Yeah, we've got 4 that we're going to look at here. So we're going to start with, again, we'll start the cycle at the lungs. And the blood vessel that brings the oxygenated blood into the left atrium, so into the heart, is the pulmonary vein. Yeah, so it's a pulmonary vein that is bringing blood towards the heart. Yeah. Then we've got, so again, left atrium down in the left ventricle. Then we've got the aorta. So the aorta is the biggest artery in the body, and of course it leaves the heart just as one blood vessel. Yeah, and that is where the pressure is going to be highest, because that is, of course, where it's closest to the squeeze. You know, it's the closest to where the force is coming from. And again, if you were to nick an artery or cut an artery, it would squirt, you know, quite far because of that blood pressure and with every single beat. So when you see it in movies, sometimes it's really exaggerated and overdone, but it's not a million miles away from the truth. An artery would spurt with each heartbeat, and it probably would cover a good distance because of the pressure, rather than just sort of leaking out. So yeah, that's our aorta, our main artery, the aorta, and it starts off as one, and like I say, it eventually branches off, and helps obviously into different arteries, and it delivers that oxygen to wherever it needs to be. Okay, then once that blood is dropped off its oxygen and it's starting to make its way back to the lungs, it comes back into the right atrium through the Vena Cava, or the Vena Cava. I guess it depends how posh you are. The Vena Cava, and then again, right atrium, right ventricle, and then forced out the bottom of the heart through the pulmonary artery. Yeah, so we've got the pulmonary artery there. So the to the lungs and from the lungs, so anything to do with the lungs, is referred to as pulmonary. Yeah, so that helps remember where those go. Pulmonary artery and vein are going to and from the lungs, I guess, if you look at it that way. Okay, then of course Vena Cava and aorta as well, and that is the heart cycle, guys. That is, you know, in 7 steps. I think we've done ourselves like a really nice visual to help us just sort of picture how the blood does move around the body, and like I say, the job that it's doing on the way, and why it works how it does. And I think that makes it nice and easy to go back as well in the future and just sort of revise on it, and just sort of revisit it, I guess. You know, it's a lot of new words, it's a lot of information to take in one sitting. We're going to do a little quiz in just a minute to see how we are doing with everything. But again, there's going to be a couple of little sneaky questions in there as well, as always. So don't worry too much. It's not like a test or an exam or anything like that. We're just going to check on our knowledge, as well as hopefully find out a few little fun facts about the heart as well. Okay, guys, cool. So pause it here if you need a little bit longer to finish up your diagram, obviously with this one on the screen to copy from. I'm going to spin on to the next slide. And again, grab yourself a pen and a bit of paper. It's entirely up to you if you want to just flip over and use the other side of your diagram, but I would recommend keeping that diagram somewhere handy, even just for now, never mind in the future if you do want to come back and look at this sort of stuff again. Okay, guys, so we have got 20 questions on the heart and how the heart works. I'm going to see how we get on. Like I say, nice and laid back, steady on, all multiple choices as well, I believe, so we can have a guess if we're not entirely sure as well. So yeah, 20 questions. Right, I'm going to just roll into the first question, and then beyond that, like I say, if I start moving any quicker than you're ready for, if you want a little bit longer, just pause it and move along in your own at your own speed. Okay, guys, 20 questions. Good luck. Right, the first question. How many times does your heart beat in a lifetime, do you think? How many times does your heart beat in a lifetime? 2.5 million, 2.5 billion, or 2.5 trillion? How many times does your heart beat in a lifetime? 2.5 million, 2.5 billion, or 2.5 trillion? Okay, I'm going to spin on then. Spin on question 2. True or false, this one. Your heart can live outside of the body. True or false? What do we think? True or false? The heart can live outside of the body. And again, you can always have a guess if you're not sure. (50-50). Okay, question 3. The bigger your heart, the better. True or false? Do we think it's better to have a bigger heart? Physically bigger, not metaphorically bigger. Because I would say it's a compliment to say to somebody that they've got a big heart. Of course, that tends to not mean that their heart is really big. So do we think a physically bigger heart is good or not? Okay, question 4. A broken heart can it actually hurt? Like physically hurt? Can it be seen on an X-ray? Or can it last forever? What do we think? A broken heart, can it really hurt? Be seen on X-ray or last forever? Okay, that was question 4. Question 5. Where in your chest is your heart? Might have given this one away earlier on as a little bit of a freebie, actually. So where in your chest is your heart? Is it left, right, or center? Question 6. How many gallons of blood does your heart pump every day? Yeah, so let's have a look in terms of liters. So I'm just going to come out of that there, actually. Convert these into liters. Yeah. So do we think it's 800 gallons, 1,000 gallons, or 2,000 gallons? And I'm going to convert those into, gallons into liters. Okay, so 800 gallons is 3,636 liters. Yeah, so thinking about those pops that you might get that are either a liter or the bigger ones that are 2 liters. So those are 2 liters. So it gives us a bit of perspective on the numbers that we're looking at here. So one of those bottles is 2 liters. So how many gallons of, or how many liters of blood does your heart pump every day? 3,600. 1,000 gallons is 4,546 liters. 2,000 gallons will be about 9, I'm guessing. Yeah, 9,092 liters. So how many liters of blood does your heart pump each day? Is it 3,600, 4,500, or over 9,000 liters a day? Either of those or any of those is a really crazy amount of blood to be passing through your heart every single day. But which one do we think it is? A, B, or C? Okay, then question 7. When was the first successful human heart transplant? Was it 1946, 1967, or 1978? When was the first successful human heart transplant? (1946, 1967, 1978). Okay, question 8, one that we should hopefully all get if we've got our diagrams on hand. How many chambers are in the heart? 3, 2, or 4? How many chambers are in the heart? Three, 2, or 4? Right, question 9. Which animals is most like a human heart, as in how they look and work? So which animal's heart is most like a human's heart in how they look and how they work? Is it A, a dog, B, a pig, or C, an ape? Yeah, is it a dog, a pig, or an ape whose heart is most like a human's, as in how they look and how they work? Okay, question 10, halfway mark, halfway. True or false again? A heart can sometimes fix itself. True or false? A heart can sometimes fix itself. What do we think? Can a heart fix itself? Okay, question 11. The heart has been linked with love at least as far back as when? The Middle Ages, Elizabethan times, or the 60s? When did the heart start to be linked with love? Because everything we've looked at this morning so far has nothing to do with love or emotion. It's all to do with oxygen, keeping us alive, and getting blood where it needs to be. The heart has nothing to do with love. So when do you think we started to make that connection? When do you think the heart began to be linked with love? The Middle Ages, Elizabethan times, or the 60s? Bear with me, I'm just going to shut that curtain because that glare's coming in a little bit. It's that time of day. Terrible. It's grey and miserable and snowing out there. Got to have the big light on. And even then, there's still light coming in from outside, blinding us. Okay then. Okay, so yeah, do we think the heart began to be associated with love in the Middle Ages, the Elizabethan times, or the 60s? Question 12, we've got another true or false. Be careful of airport security machines if you have a pacemaker. True or false? What do we think? Be careful of airport security machines if you have a pacemaker. True or false? Okay, rolling on. Question 13. What do you call the wall of muscle that separates the right and the left side of the heart? That thick wall of muscle down the middle that we talk about being so important. What do we call it? Is it the atrium, the ventricle, or the septum? atrium, the ventricle, or the septum? They're all words that we've used this morning, but which one is that wall of muscle down the middle? Okay. Question 14. When blood enters the heart from the lungs, is the blood oxygenated or deoxygenated? So when blood enters the heart from the lungs, is it oxygenated or deoxygenated? So is it carrying oxygen or is it not? So think about it. When it comes to the heart from the lungs, has it picked up oxygen or has it not? Okay. What is considered a healthy resting heart rate? So our resting heart rate is the amount of beats that our heart is doing per minute when we're at a point of rest. Yeah, when we're not really active, we're not really doing any activity. So what is considered a healthy resting heart rate? Is it 100 to 120 beats per minute? Is it 80 to 100 beats a minute? Or is it 60 to 80 beats per minute? What is considered a healthy resting heart rate? 100 to 120 BPM, 80 to 100 BPM, or 60 to 80 BPM? What's considered a healthy resting heart rate? A, B, or C? Okay, question 16. What is the name of the main artery that pumps blood around the body? So the main artery, is it the atrium? Is it the aorta? Or is it the pulmonary vein? What is the name of the main artery that pumps blood around the body? The atrium, the aorta, or the pulmonary vein? Okay, question 17, last few. What are the top two chambers of the heart called? So the top two, the aorta, the atrium, or the septum? What are the top two chambers called? The aorta, atrium, or septum? And that's the top two chambers. Okay, in case you didn't see it coming, what are the name of the bottom two chambers of the heart? Is it the ventricles, vein, or vena cava? So the bottom two chambers of the heart. Ventricles, vein, or vena cava for the bottom two chambers of the heart. Okay, last two then. How big is your heart? Is it the size of an orange? Is it the size of your own head? Or is it the size of your own fist? How big is your own heart? Size of the orange, size of an orange, size of your head, size of your fist. Question 19. Done. Question 20 then. Last one. When our heart beats, is it voluntary or is it involuntary? Yeah, so is it involuntary is A and voluntary is B. So when our heart beats, is it involuntary or is it voluntary? Yeah, do we tell our heart to beat? Okay, everyone, thank you so much for giving that the best that we can. Let's go back through and I'll give you the answers and see how we did. Right, so all the way back to question 1. Right, let's break it down then. Let's break it down. So how many times in your life does your heart beat, do we think, As always, if you're watching along in the chat and you want to pop anything in, let me know. Let me know what you guessed. Let me know what answers you went for. It's having a minute just loading itself there, but I do keep an eye on it as we're working our way through, just playing catch up. How many times did your heart beat in a lifetime? Is 2.5 billion. It's 2.5 billion times in your lifetime your heart may well beat. And if we assume that, say, I know it's a bit of a assumption, but if we say that we maybe live to an average age of about 80, so 2.5, right, hang on. 2.5 billion, there we go. Divide by 80. That's 31 million beats a year. Upwards of 31 million beats a year-ish. Wow, that's insane. That's insane. I've never done that. I've never done that one before. That's crazy. But yeah, 2.5 billion times in your lifetime your heart will beat. So it was B for question 1. Question 2, your heart can live outside of the body. Is true. Heart can live outside of the body. I remember reading I was looking at a news story at the start of this year, actually. There was a lad who, I believe in America, there was a lad who he was waiting on an operation and he was carrying around a heart in his backpack. His heart was in his backpack while he was waiting on this operation, and it was fine. That the heart actually has its own electrical current which helps it and makes it beat. Yeah, it's almost got like its own little battery, like it's like I say, a totally separate system to everything else that goes on in the body. The heart can beat outside of the body. Yeah. So yeah, that is true. Actually, question 2 is true. Question 3: the bigger your heart, the better. Now, like I say, it's meant to be a compliment and a term of endearment, where you would say that somebody's got a big heart, you know, if they're sharing quite a lot, or they've got a lot of compassion and emotion for other people. It's more a figure of speech, though. A bigger heart can actually cause health problems and put us at risk. So a bigger heart isn't really a good thing, and you may need medication to treat it if you do have an enlarged heart. So the bigger your heart, the better is actually false. Question 3 was false, guys. Okay, question 4. Again, if I'm moving a little bit quick, by all means do let me know. But you can pause and catch up whenever you fancy as well. Okay. Question 4. A broken heart can, what do we think, really hurt, be seen on an x-ray, or last forever? It's A. It can really hurt. It can physically hurt, and it's meant to be, allegedly it's to do with hormones in your body. Your body will release different hormones based on your feeling of losing somebody, that feeling of loss, that broken-hearted feeling, and that is what causes the that's what causes the pain. That's what leads us to feel in pain. So that might be linking into that other question. That might be potentially why the heart started to get looked at as something to do with associated with love as well, because you end up with that sort of pain in your chest. So a broken heart can actually hurt. Question 5: where in your chest is your heart? Remember, we mentioned that one earlier on. Your heart is, of course, nice and central in your chest, right behind that sternum, right behind that breastplate or that breastbone, and it is slightly tilted over to the left-hand side. And actually, now we've got our diagrams. If we go back to our diagram, fully completed, the left-hand side is the side of the heart that deals with oxygenated blood. And that is why the left-hand side contracts harder than the right-hand side. It needs to force that blood everywhere in your body that needs oxygen, which is why that left-hand side pumps harder which is why the beat on the left-hand side of our chest is stronger than on the right-hand side, which leads us to thinking that it's on the left. I mean, if you stand up and do the national anthem, where'd you put your hand? Yeah, it's apparently across your heart, but no, your heart is nice and central. Okay, question 6 then. How many gallons or litres of blood does your heart pump each day? So we've got 3,636, 4,546, again, average, on 9,092 litres a day of blood every single day. Now for this one, hope you're sitting down. It is C, guys. It is C. It is over 9,000 litres or 2,000 gallons of blood a day pass through your heart. So again, come back to those 2-litre bottles of pop. It's 4,500 of them every single day is the amount of blood that goes through your heart. And that just shows you how important it is, but also why it's important to keep those blood vessels, those veins and those arteries and your valves blockage free. Yeah, we need to allow this to happen. There's that much volume going through. We need to keep it as clear as possible, which is why our bad diet, our saturated fats that start to clog up our veins and our arteries and make it harder and only increase our blood pressure as well, because there's less space in there for the blood to actually be, because of all the junk that's getting deposited in there as well. So we need to give our heart half a chance by getting some good food and some exercise as well to help it strengthen, just like any other muscle. Okay, question 7. When was the first successful human heart transplant? 1946, 1967, or 1978? And the answer to this one was 1967, actually. So a good bit earlier than I would have thought, that's for sure. To say that, like, I think of obviously 1966, we won the World Cup. The footage is all grainy and black and white. It was hard to imagine that just the year after that, we were completing successful heart transplants, when that was where video technology was at the time. But that is the case. It wasn't the first attempted human heart transplant, but it was the first successful one where the individual lived. I actually died relatively soon after, but that was due to, I believe, pneumonia. It was complications from the operation and not from the fact that his body was rejecting the heart. So his body accepted the heart, which is why it was considered to be the first successful human heart transplant. Although he didn't live many years after. And yeah, it was 1967. So just after we won the World Cup. And I'm probably going to say, maybe it's even at the height of Beatlemania, whenever that may have been. I wasn't around. If anyone wants to let us know when Beatlemania was, by all means do. But I know they were big in the 60s. So yeah, 1967, guys, first successful human heart transplant. Okay, question 8. How many chambers are in the heart? Again, we've got a diagram we can use for a little bit of revision. Go back and check. And it is 4. We've got 4 chambers in the heart. If we remember, 2 at the top, 2 at the bottom, divided wall down the middle. Okay, so which animal's heart is most like a human's in terms of how they look and work? Okay, so was it a dog, a pig, or an ape? And the answer to this one is actually an ape. Of course, gives potentially some evidence towards the fact that we evolved and potentially even sort of descended from apes as well, and well, yes, like primates. So yeah, in terms of how it looks and how it works, the ape's heart is the most similar to ours. However, there is procedures that get done these days, and just off the top of my head, I know particularly to do with like valves. Again, I mentioned those valves in the heart that only allow blood to go one way. They let blood through and then they close and stop the blood flowing back over. And those valves can get damaged in time. Again, you know, age, wear and tear, poor lifestyle and dietary choices, those valves can start to suffer. So you can get something which is called a valve transplant, and you get a new valve put in that isn't crusted up with fats and whatever it might be. And they put this new valve in, and they can actually now transplant valves from pig hearts. So we can use pig hearts in a human body, even though the ape's heart is closer to our own. Yeah, and I think that's absolutely fascinating that we can take something from a pig heart, put it into a human, and extend life. You know, it's crazy. So that one was C, question 9. Question 10, a heart can sometimes fix itself. True or false? Is actually true, and it's the same with most organs. If you are dietary choices, you know, again, lack of exercise, and they're starting to degrade and starting to get damaged, you know, it's the same as like if you smoke a lot and obviously it's affecting your lungs. If you stop smoking, your lungs, your heart, whatever it is, will may begin to repair itself. It needs the chance to do so, but it can actually do it. Yeah. So again, like I say, if you drink a lot of alcohol and you know your liver's suffering, if you ease up on the alcohol, your liver can actually start to repair as well. So our internal organs are absolutely fascinating things, and the facility that the body has to repair itself is pretty amazing. So question 10 is true. The heart can sometimes fix itself. Question 11, the heart has been linked with love at least as far back as when was it? The Middle Ages, Elizabethan times, or the 60s? And it's actually the Middle Ages. Heart has been linked with love at least as far back as the Middle Ages. So quite a long time to say that the heart, again, doesn't have anything to do with our emotional connections, really. So A for that one. Question 12, be careful of airport security machines if you have a pacemaker. True or false? And it is, of course, true. Anything like that gives off like electric signals when it's scanning or whatever it is something that you need to be aware of if you have a pacemaker, as it might interfere with the current of your pacemaker as well. Yeah, so if you've got a pacemaker in your heart, which is just a device that they'll put in to help keep a constant regular heartbeat, you do need to be careful of things like airport security machines. So 12 was also true. Question 13 then. Question 13. What do you call the wall of muscle that separates the right side from the left side of the heart? Was it the atrium, the ventricle, or the septum? And it was, of course, the septum. Same as down the middle of your nose, which is a septum piercing. The septum is the thick wall of muscle that separates the right side from the left-hand side of the heart as well. So C for question 13. Okay, question 14. When blood enters the heart from the lungs, is that blood oxygenated or deoxygenated? Is it carrying oxygen or is it not? It is, of course, oxygenated. So when blood enters the heart from the lungs, remember the lungs is where it picks up the oxygen, because that's where the oxygen comes into. The blood comes past the lungs. So from the lungs, when it enters the heart, it is oxygenated. Yeah, so question 14 is A. Question 15. What is considered a healthy resting heart rate? So 100 to 120 beats per minute, 80 to 100 beats per minute, or 60 to 80 beats per minute? And the answer is, of course, C, 60 to 80 beats per minute. And you can actually check your own. You might have a Fitbit or like an exercise watch that'll tell you, but if you don't, what you can actually do, you can take these two fingers, avoid using the thumb, these two fingers, and put it on your wrist or on the side of your neck until you can feel a pulse. And then all you do, set a stopwatch away for 60 seconds and count how many times it beats in that 60 seconds. If you want to save yourself a bit of time, time it for 30 seconds and then double it. But you can actually check your own resting heart rate or your own heart rate at any point. You can do it when you've been exercising and see what the difference is. But yeah, having an idea where your resting heart rate is can give you an idea of how healthy you are there and then. Okay. Okay, question. Question 16. What is the name of the main artery that pumps blood around the body? Was it the atrium, the aorta, or the pulmonary vein? And it was the aorta, the main artery. Again, we can go back to our diagram and we can see the main artery that sends blood around the body is the aorta. Yeah, so it sends blood around the body, and that's the aorta, this artery in the body. Where were we? Okay. So 16 was B. Question 17. What are the two chambers of the heart called? Is it the aorta? We're not that one because we've just had that one. It's not the septum because we know that the septum's the thick wall of muscle down the middle. So it's got to be the atrium, guys. And remember, again, the top two chambers, it's where the blood flows into. So it's sort of open topped and like an atrium in a building as well. Yeah, so atrium is at the top, which means that the bottom two chambers are the only ones that we've got left is A, ventricles. We know that veins are blood vessels and of course help us transport blood around the body. And the vena cava, if we weren't sure, again we can go all the way back to our diagram, that last finished diagram, and see, okay, vena cava is the blood vessel that brings deoxygenated blood back to the heart. It can't be that one. So it can't be the vena cava. So yeah, with ventricles at the bottom. So atrium at the top, ventricle at the bottom, left side and the right side. And last two, how big is your heart? Is it the size of an orange, the size of your head, or the size of your fist? Your heart is about the size of your fist, actually. So you can get an idea roughly how big your heart is. And of course, it's relative. A person who is bigger is going to have a bigger fist, but will also have a bigger heart. Yeah. So when we talk about is a bigger heart better, it's all relative. Your heart size is going to be relative to your physical size as well. So yeah, your heart is about the size of an orange. No, it's not. It's about the size of your fist. Sorry. So you can get an idea, like I say, roughly how big it is and how much space it's taken up in your chest. So yeah, about the size of your fist. So question 19 was C. And question 20, when our heart beats, is it voluntary or involuntary? It is, of course, involuntary. We don't control our heartbeat. We can manipulate it, but we don't. We couldn't really, if we wanted to tell our heart to stop beating, we couldn't. I can tell, I can tell my neck muscles to stop twisting my head from side to side, but I can't tell my heart to stop beating. And that is the difference between voluntary and involuntary. Yeah, so question 20 is, of course, A. Yeah, it's involuntary. Our heart beats by itself. So how did we do, guys? I'm always curious to know. Like I say, if you did want to drop me a message and let me know, by all means do. The chat seems to be having a bit of a nightmare this morning and won't really update itself. So if you have popped anything in the chat that I've missed, I do apologize. I'm going to try and find a way I can get in there and just make sure I haven't missed anything, if I can just get it caught up to speed. The joys of technology here, but I guess without it, we wouldn't have been able to be online, staying connected and learning about our health and our own well-being for the last 18 months as well. So swings and roundabouts, guys, pros and cons. And that is everything that we needed to run through this morning, actually. So we've had a good look at the different types of muscle in the body and the different classifications and characteristics of them. We have, of course, looked at where those organs are as well. We've looked at the organs in the body, the job that some of those do, and learned some fun facts along the way. And of course, we've actually got, hopefully now in front of you, a full diagram of how the blood moves around the body and how the heart works that you can use whenever you need it, really. I guess there's a little bit of a revision tool or something that you could go back to as well and sort of revisit, touch on again. Or maybe even just go back to sort of reinforce that information as well. I know full well from doing my personal training course that certain things. I was the same with muscles, and sometimes the heart as well. It pays to look at it more than once to help it sort of really settle in and really start to make sense. But that diagram will really help as well when you do come back to it. And we can leave it there, guys. Actually, we can leave it there. Obviously, there's no workbooks or anything with our pre-employability course, so don't worry about anything like that. All I need of you each week is just a survey. Yeah, just click that link in the description, fill in that survey. That won't even take 30 seconds, and that is all I need from you, really. Like I say, no workbooks or anything like that. If you need anything before next week's session, again, my email is found in that description section under the video in case you need it. You've probably already got my email because, of course, I'm sending these links out to pretty much everybody every week anyway. But if you don't and you're seeing this and you want it, it's in there. And of course, if you need me for any reason, it's in the description. Don't forget to check out this week's fitness video as well that we've linked in with today's session. Of course, each week I'm providing a different fitness session for you to do and try, just as something a little bit different, stuff that doesn't need a lot of kit, or usually any kit, really. And there's always alternatives to different exercises as well. If you find that, you know, your knee doesn't like a particular movement, or your hip or your back or whatever it might be, you know, not all exercises are for everybody. So I've made sure that there's a good mix of videos up there as well. So if you click that link, which is also in the description, to go to the fitness video, if you're not really feeling the video that it pulls up, you know, it might be an abs video and you might think, oh, I fancy doing some upper body this week. You know, I might want to do my legs a little bit. Still follow that link. It'll take you to the YouTube playlist, and then you'll be able to pick one of our many sessions from there. So you can have a look and say, okay, I want to do me legs and bum or whatever it might be, or upper body and lower body today. So yeah, by all means have a look. There's stretching videos on there, there's sessions you can do sat down, there's a little bit of something on there for everybody as well. So we've all got an excuse to be active and to be moving this week, and hopefully each week going forward we'll be trying to get a little bit more active and a little bit healthier as well, and we'll have a good head start for coming into the new year, that's for sure. We will, of course, be back next week with, I believe, session 4. In fact, let's have a quick little look at what we're going to be looking at next week. Where we are, session 4. So next week, we can actually be looking at, it's a really good one actually for coming into Christmas, paired eating habits and overeating, how we end up overeating. And it's quite an interesting one actually. There's a lot more to it than you might think. So yeah, tune in next week. We'll be back next week with a brand new session to do. But yeah, please don't forget to do that survey. And we will be back next Monday, same time, 10 till 12ish. Of course, including the fitness video as well. And we'll have one session left to do after that. So if, like I say, if you need me in the meantime, let me know. If not, guys, I will catch everybody back here hopefully next Monday for another session. We'll keep the ball rolling, and we'll have a little bit of a deeper look at some of our food and our food choices as well. But thank you so much for logging in. Thank you for learning with me, Savvy. And as always, take care, stay safe, look after yourself and those around you. And we will be back next week to do it all again. Until then, guys, stay safe, take it easy. I'll see you later.